right, so all right, verifying trig identities is basically what it says we're doing. And let me turn on some lights so we can see better here. Let me see if people at home. All right. Hopefully you people at home can hear me now. It's muted. Okay. All right. So we're going to be verifying these trig, and what they want you to do here is we steps through this. Basically, what's going to happen is it says you'll study techniques for verifying identities. Basically, you're going to be given two things that are equal. And like I said before, you're going to substitute in these different identities and change the left side of it to where it will equal out what is on the right side. Let's see. That's not really what we're looking at. All right, so here are the guidelines to doing this that they say. You want to work only one side of the equation at a time. And you generally, the side that looks more complicated is where you want to start with. You look for chances to factor. So you got to bring in your factoring things. Add fraction, square binomial, create a monomial denominator. Look for places to use these identities. This says when the preceding guideline does not help, try converting all terms to sines and cosines, right? Anytime you have a tangent, you can change it to sine over cosine. If you have a cotangent, you can change that to cosine over sine. So there's ways to get around using cotangents and tangents. If it's a cosecant, you can change it to 1 over sine. If it is secant, you can change it to 1 over cosine. All right. Always try something, even make an attempt that leads to a dead end provides insight. So sometimes you start down a path here and it doesn't get you to where you want, and you sort of have to start over. It's like I said, like a puzzle. So here's what's going on. So we've got secant squared of theta minus 1 over secant squared of theta equals sine squared of theta. So what we're wanting to do is use these identities, factoring, any kind of thing to prove that these two are equal to each other. All right, so they say because the left side is more complicated, start with it. So if you'll notice what they did, they got secant squared of theta minus 1 equals tangent squared of theta plus 1 minus 1. Now, where did that come from? Okay, well, if you'll go to, it is the Pythagorean identities. On the Pythagorean identities, we have 1 plus tangent squared of u equals secant squared of u. So where secant squared of theta is, it is equal to 1 plus the tangent squared. So that's all they did was a simple substitution. That's where they get tangent squared of theta plus 1. All right. Now, obviously, the next step is going to be is there's nothing in front of that parentheses, so that plus 1 minus 1 is going to add to 0. And I'm going to end up with tangent squared of theta over secant squared of theta. And notice that's what they get. Now, the next step they do, all right, is they look at secant squared. And if I go back to my reciprocal identity, secant squared, or secant is the same as 1 over cosine. Okay, let me see if I can write this down on top of this so you can see what's going on. know if this will work. I may need to do the actual, see where we are. All right, so from the identity, having issues. All right. Previous. Pin. All right, so from here, what we know is from that is that the secant, and we can put theta, secant of theta is going to be equal to 1 over the cosine of theta. That is a reciprocal identity. So what we're going to do, or that's where if I replace the secant squared of theta, I'm basically going to replace it. I'm going to have tangent squared of theta. I'm going to replace it with 1 over cosine squared because it's squared, it stays squared. All right, and then whenever I divide, tangent is squared divided by 1 over, that's the same thing as multiplying by the reciprocal, and that's where I end up with the tangent squared of theta times the cosine squared of theta. Now, also, as I back up, you do need to recognize what you want it to equal to. So it's going to equal to sine squared. So as I'm working through this, I need to find things that would equal to sine. Like sine, if I can get a cosine and a tangent, that would possibly bring in a sine because the tangent is sine over cosine. If I could get a cosecant, that would lead to a sine. You know, different things like that. So what they'd have now here is tangent squared of theta equals cosine squared of theta. That's where that came from by substituting in for the secant squared. All right, now what could I possibly do? Well, tangent, I know tangent is sine over cosine, and I'm needing to get to a sine. So that would bring a sine into my problem. So notice what I'm going to do is I'm going to replace tangent because the tangent is equal to sine over cosine. What I'm going to have is sine squared of theta over cosine squared of theta times cosine squared of theta, which that's there. And then if you'll notice, if I put cosine squared of theta over 1, cosine squared of theta cancels, and I end up with sine squared of theta, which is what they were wanting me to look for. So this is just the idea of it's a puzzle. You have to substitute in different things. You want to look at what would get you to what you want. Like I know I needed it to be equal to sine, so I sort of look through ways. Anytime I have a tangent, that may mean I need to change it to sine over cosine because that would bring in the sine. But it's more of it's really just trial and error. This is there's no just one way to show you how to do these and then it works through. They're just going through the same thing we just did there. So let me pull up the let's see, I need to get out of this in show. Discard those. Let's pin that. All right, we are looking at 5.2. So if I view this assignment, so here's just some problems off the assignment. The first, this one right here, 1 over tangent of u, basically that's just looking it up. What's that equal to? That's a simple reciprocal identity. Tangent of u equals 1 over cotangent of u, so 1 over tangent of u is going to equal cotangent Same thing there. The trig identity, sine squared u plus what equals 1. That's just a Pythagorean identity. Here's the next one is just an even odd identity, pulling it straight off that sheet. Now here is this one right here, which is a little tough to see. Let me see if I can enlarge that. Tools, capture. No, that's not what I want. Capture. Well, let me see if I can just rewrite it. So what it's given us is 2 secant of y cosine of y equals 2. And they've done part of the problem for you. What they're done is they are now saying, okay, this is going to translate into 2 over what times cosine of y would equal 2. So what they're wanting to do is just 2 secant of y. What does that equal? 2 secant of y. Well, if you go to the reciprocal identities, secant equals 1 over cosine. So this becomes 2 over cosine of y, which would lead to cosine of y's canceling, and then you get 2 equals 2, which is proven the identity. Same thing here. This one, let me move this out of the way. You got 4 sine squared of t over tangent squared of t equals 4 cosine squared of t. Well, what my mind goes to right here is I know tangent is sine over cosine. And if I can change that to sine squared over cosine squared, then possibly those sines are going to cancel. I'm going to leave me with the cosine, and that's what happens. It gets a little confusing the way these boxes, but the boxes are just they're looking for what you want to put in there. What did they do? So notice here it's a box over cosine squared. Well, they just changed tangent squared to sine squared over cosine squared. And then when you multiply by the inverse, the sines cancel, the sine's right there in the denominator, and then it cancels and leaves you the 4 cosine. So basically, all of these, it's got the blanks filled in. You don't really have to do much of the work yourself. You just have to fill in what blank are they substituting into? What identity are they using to substitute for this into this box? So that's basically what's going to go through. So it's basically you just have to figure out what is being substituted in, and then you might have to do a little bit of figuring on what's canceling or how did they get to the next step. But most of it is set up for you. Let's see if we can figure out what they did here. Secant over tangent. They just went to those cofunction identities and replaced both of them with directly what's there. So you need to have those sheets of paper in front of you. If you have those sheets of paper in front of you, it's going to be fairly easy. So you people at home, you might want to print them off or just at least get screenshots of them so you can use them. That's what's going on in all of these, just 11 problems. So I'm going to go ahead and assign this.